Today we're going to be discussing lab number 35, which is finding the activation energy of a reaction. And the reaction is the same reaction we used before, which is between crystal violet and sodium hydroxide. In order to find the activation energy of this reaction, we need to find a relationship between temperature and rate constants. You'll recall that we did lab number 30 where we ran this at just room temperature and we were able to graph the absorbance of crystal violet versus time, and we were able to determine the rate constant. And because we found out it was first order, when we made the graph, we found that we needed to take the ln of absorbance versus time, and we got a straight line. And the slope of that line was equal to the negative of the K, but that was specific to that temperature, of room temperature. So now what we're going to do is we're going to run this lab 4 mini versions, and we're going to do them at 4 different temperatures. We're going to do about 10 degrees Celsius, 15 degrees Celsius, 20 degrees Celsius, and 25 degrees Celsius. And like I said, we're going to run a mini version of this lab 4 different times. So what we're going to do is we're going to have a bath, and you're going to have to get the bath to about these temperatures one at a time. So let's say we're about 10 degrees Celsius, and it's going to be a shallow bath in a big beaker because you have to get your reagents to be in small beakers and get to that temperature. So the first beaker is going to have your crystal violet, your second beaker is going to have your sodium hydroxide, and this is going to be your mixing beaker, and they all have to sit in the bath to get to the temperature of the bath. All right, you're going to have about 10 milliliters of each of these. You're going to measure that accurately with a graduated cylinder, 10 milliliters of each. You're going to leave them in the bath for a while, and then once they've gotten to the temperature of the bath, you're going to put them in the mixing beaker, and you're going to wait for about 1 minute before you start hitting, before you put in the colorimeter, but you're still going to hit collect. All right, so just follow the directions in the lab for that. Once you've mixed, you're going to need to rinse your cuvette, don't forget. And of course, you've already calibrated. Rinse your cuvette 2 times. Not only is that going to clean your cuvette, but it's actually going to get it to the right temperature as well. So let's move this up a little bit. And now you're going to use your colorimeter, and you're going to put your cuvette in your colorimeter. Remember that the ridges are going on the sides because you have an arrow here to remind you that the light goes this way. And you're going to leave it in the colorimeter for 1 minute. It's just going to collect for 1 minute. In the other lab, remember, we took it out every minute and put it back, took it out, put it back, because we didn't want it to heat up and affect the reaction rate. Because we're only doing this for 1 minute, it's probably not going to change temperature significantly if we're only collecting for 1 minute. Okay, so once we collect for 1 minute, of course, it's going to be collecting absorbance versus time. All right, so you're going to be collecting absorbance versus time, which is going to be a little bit of a curvy line. And so you're going to turn that graph into this graph, and you're going to have negative K as your slope. So that's going to be your run at 10 degrees Celsius. Then you're going to repeat the same exact thing at 15, 20, and 25. And so what you're going to have is you're going to have 4 different lines on this graph. And because you have 4 different lines, you're going to have 4 different slopes. And once you have 4 different slopes, you're going to have now a bunch of K constants that correspond to a bunch of temperatures. And this is where we will use our final graph to find the activation energy. So activation energy is going to come from the slope of this graph, where you're going to take your rate constants and take the natural log of the rate constants and graph that as 1 versus 1 over temperature in Kelvin. That's going to give you a straight line like this, and the slope of this line equals the negative of the activation over R. Remember that R is 8.31 joules per mole Kelvin. So your activation energy, of course, is going to be in joules per mole. Now, I want to just clarify something that may be confusing to you. You see that this relationship here is ln of k. And you see that this relationship up here is ln of absorbance. These two ln's have absolutely nothing to do with each other. This reaction between crystal violet and hydroxide, this is OH minus, by the way, okay, this relationship with crystal violet and hydroxide happened to be first order. So that's why this graph was ln absorbance versus time. If this had been 0 order, this just would have been absorbance. And if this had been second order with respect to crystal violet, then this would have been 1 over absorbance. Okay, so you had to pick the right relationship from lab number 30, and that happened to be the ln of absorbance. No matter what this graph was over here, 0 first or second order, no matter what graph that turned out to be, when you do this lab and you get all your Ks, no matter what, you would always be taking the ln of k versus 1 over t. That's always going to be the relationship of the constant and temperature, regardless of what order the reaction is. It just so happens this is an ln and the other one is an ln as well, but they're completely different ln's. So once you plot, again, your ln k versus 1 over t in Kelvin and get the slope and get your activation energy, you will have the activation energy of that reaction. The last thing you're going to need to do in this lab is to find the K at a different temperature. So if you take this graph and your calculator is going to tell you your A value and your B value, well, what is your Y? Your Y is the ln of K. Your A is from the calculator. Your X is 1 over T in Kelvin. And your B is from the calculator. So you really have two variables in this. You have the K and you have the temperature in Kelvin. So in the lab it says find the K at 40 degrees Celsius. You change it to Kelvin, take all your A and B values, and then find the K at that temperature. Or I could give you a K and say find the temperature at which that would be the constant. So that's the final calculation you're going to have in this lab.